The A4 Skyhawk, a rugged breed, proving once again in the skies over Southeast Asia its reputation as one of the most valuable tactical aircraft now in service. Skyhawks, first-line light attack aircraft for the U.S. Navy and U.S. Marine Corps, capable of delivering all tactical weapons. Operating from land bases and from offshore carriers, the Skyhawk has repeatedly demonstrated its ruggedness and versatility as a ground support aircraft, performing a large percentage of all Navy and Marine attack missions during several years of combat. High operational availability has been a prime virtue of the Skyhawk. In Southeast Asia, availability has averaged well over 80% for operating aircraft. Inherent in the Skyhawk design is ease of maintenance, low cost. Whether to repair combat damage or for overhaul, the airplane can be dismantled easily into 4 major sections. Today's Douglas A4 Skyhawk evolved from years of operational experience. It was conceived as a simple, lightweight, carrier-based aircraft capable of carrying heavy ordnance payloads at high subsonic speeds, a unique design concept in a field where jet planes are generally becoming larger, more complex, and more expensive. Throughout 6 major model changes, the Skyhawk has kept pace with ever-changing, ever-growing tactical requirements. A continuing $200 million improvement program has made today's Skyhawk a modern, integrated weapon system. Avionics capability has kept pace with weapons delivery requirements. To accommodate new weapon capabilities, store stations have been increased from 3 to 5. And over the years, many aerodynamic and structural improvements have been made. Power plant growth has paralleled these improvements. In this model, 20% more thrust than early model Skyhawks. Improved maneuverability and acceleration. This is the A4, a weapon system proven in combat. Sharing these advanced capabilities with the A4F is a 2-place version, the TA4F. It combines the features of combat Skyhawks with new trainer capabilities. Its full combat capabilities are used in forward air controller missions, armed reconnaissance, as well as for combat training. The TA4J, the advanced jet trainer, cost simplified derivative of the TA4F, designed for advanced jet training of student pilots. Both cockpits have flight controls and instruments for all-weather flight training. And to meet the challenge of the 70s, the newest member of the Skyhawk series, the A4M. 20% more power than the A4F, greatly increased maneuverability, greater combat effectiveness. The key to these capabilities? The improved Pratt & Whitney J52 engine, the P408, delivering 11,200 pounds of thrust. With nearly 2,000 pounds more thrust, the A4M requires 1,500 to 2,500 feet less runway, 50% greater rate of climb, 50 knots faster, 100% greater maneuver, 23% better longitudinal acceleration. This major expansion of the Skyhawk's operational flight envelope, together with the high inherent strength of the A4 design, greatly improves its already excellent combat survivability. Also new in the A4M Skyhawk is the enlarged cockpit enclosure, providing greater head clearance and freedom of movement. The larger canopy with a windscreen similar to the 2-place Skyhawk greatly increases pilot visibility for search and target acquisition. The addition of the dorsal pod, standard on late model A4s, provides additional space for the latest avionics equipment. Firepower of the two 20mm cannons has been doubled, from 200 to 400 rounds. A new sight, accurately bore-sighted, adaptable to gyro-stabilized lead computing and ranging for improved weapon accuracy. With full ordnance load, the smokeless A4M reaches high subsonic speeds at low altitude. Wing lift spoilers improve its crosswind landings. With the new drag chute and spoilers, landing rollout is greatly reduced, resulting in a true operational short field capability for the Skyhawk. Handling is greatly facilitated by the steerable nose wheel. But it is in the air that the true worth of any tactical aircraft is demonstrated. Among military aircraft, the Skyhawk has achieved an outstanding record of safety and survivability in over a decade of operational service. Its dual hydraulic-powered flight controls are backed up by manual controls. Emergency free-fall landing gear is provided. The latest model Douglas Escape Pack ejection system provides escape throughout the flight envelope, including zero speed and zero altitude. The availability of the A4M as a leading tactical aircraft in the 70s is assured by an established production line for both single and two-place Skyhawks. The proven effectiveness of the Skyhawk design, the new and growing capabilities which continue to be added to it, have made it a first-line attack aircraft, not only for the U.S. Navy and Marine Corps, but also for the air forces of 4 other nations of the free world. With the full product support of McDonnell Douglas, the Skyhawk is and will continue to be a most formidable weapon system for today and tomorrow.
Here is the familiar Hawk, lean, strong, and swift. Its rhythm and grace are beautiful to watch, yet it is deadly and accurate. For its very well-being is dependent upon its ability to maneuver crisply and strike with the speed of lightning. Here is another Hawk, the Douglas Skyhawk, also familiar for its lean, powerful, and graceful performance. It is deadly and accurate, and like its namesake, carries no excess weight, no frills unnecessary to its function as an attack bomber. Its size, weight, and design simplicity startled the aviation world. The versatility, reliability, and tremendous firepower has made the Douglas Skyhawk the most outstanding attack bomber in the world today. The A4D Skyhawk, or DA-101 as the export version is called, is an extremely small, high-performance, high-payload military attack bomber. The Skyhawk is so small, it can be stored on carriers without folding its wings. So fast that it can operate as a fighter. And so powerful, it carries a bigger striking load farther and faster than any airplane of its size. It is only 39 feet in length, with a wingspan of 27.5 feet and a height of 15 feet. The weight of the aircraft is 15,000 pounds. It is powered by one Wright J65 turbojet with a thrust of 7,700 pounds. The Skyhawk is the result of Douglas's long experience in the designing and building of all types of combat aircraft. Its revolutionary design is the outcome of a new Douglas philosophy. It was this reasoning that brought the Skyhawk into being. It was this departure that furnishes more performance per pound of airplane. One of the first steps taken was to simplify and conventionalize the fuselage structure for ease of field maintenance and for ease of manufacture. As well, considerable weight saving was effected through the reduction in the number of joints in these structural members. A novel design approach was used on the cockpit. All internal stiffeners were eliminated, and the external skin used as the strengthening agent. This approach lessens the overall weight and furnishes maximum internal space with minimum external shape. Another example is the method of attaching the wing and landing gear to the fuselage through the use of an attach fitting integrally machined with the spars. A classical example of obtaining the highest possible utility from the structural design is the wing. An obvious proof of the compounding value of the weight-saving program is displayed in the small, modified delta wing surface. Because of the reduction in airframe weight, it became possible to reduce the wing size. An added dividend because of its small size was the elimination of the need for wing folding mechanism. Needless, this elimination created an additional saving in weight, plus the added factor of considerable savings in costs and personnel. To further save space with resultant weight reduction, the design of the small wing provided for the use of the internal wing structure for integral fuel tanks. Thus, a secondary function was achieved without disturbing the primary purpose. Another example is the use of strong points in fuselage design to provide attach points for high-load carrying devices. The efficient structural design permitted the arresting hook to be carried directly into the fuselage longerons. Again, the result was effective weight saving and lower cost. Reliability of structures and components was given major consideration during the concentration on lightweight design. Very high reliability percentage was achieved through simplicity rather than by excessive strengthening practices. It showed that concurrent with structural weight elimination, all internal systems and their components were miniaturized and thus lightened without loss of performance capability and with further savings in costs. The ejection system incorporates all the necessary safety features proven during Douglas's long experience. The system was designed to be especially lightweight, weighing approximately 50% less than systems in general use, and has proven to be extremely rugged and capable of withstanding high loads. The Douglas designed system is fully automatic and provides reliable escape even from ground level. And in addition, the system contributes much to the aircraft performance through its light weight, and as well provides for a low maintenance rate and maximum reliability through the greatly simplified design and mechanical function. As a result, the A4 Skyhawk suffered no strength restrictions because of these economies and size reductions. The aircraft has, in fact, emerged as an extremely rugged end product, a fact which has been proven during actual operational conditions. Function has ruled rather than redundant bulk. Seeing is believing. The Skyhawk is a small aircraft, but immediately the question arises, what about the payload? Here is the tremendous arsenal carried by the Skyhawk. Here are weapons for every tactical situation, as well as tools for mobility and range when required. Here is a payload available in single-type loading or in combined loading. The versatility, the interchangeability, assures the right weapons for a given job. Smaller weapons are arranged under the strong, rugged wing. Lightweight bombs, rockets, napalm tanks, and gun installations. To facilitate centerline under-fuselage loading of extra cores, the landing gear was designed with extraordinary ground clearance. This permits the larger bombs to be carried in a position that avoids asymmetrical flight characteristics. In addition, the high ground clearance permits the pilot to land the aircraft with these large stores when a mission is aborted or the stores unused. An excellent example of the benefits of the added ground clearance is the capability of attaching large fuel tanks along the fuselage center line. This enables the Skyhawk to be converted to an in-squadron tanker aircraft. The underside tanks and associated transfer equipment greatly extend the jet squadron operation. In addition, it permits rapid deployment and furnishes the opportunity for a highly mobile force wherever long-distance moves are required. The refueling system is a complete powered system capable of containing and transferring 300 gallons of jet fuel. More fuel can be drawn from the aircraft main tanks should additional supply be required. The economy inherent because of this innovation is readily apparent. The high cost of maintaining expensive tanker aircraft is avoided, and the lag time usually required to schedule and arrange rendezvous with the tankers is non-existent. Thus, it can be seen that economy is foremost in the Skyhawk. Its small size, its tremendous payload, its versatility of external loading, all lend toward making it the most practical ground support attack bomber for the coming years. What do these successes in functional design mean in the actual costs? They mean a defense budget saving of better than 50%, or in terms of defense units, twice the number of aircraft for the same expenditure of defense budget. Maintenance and manpower requirements are also areas where costs and performance efficiency can be increased or decreased. The basic design philosophy has taken these areas into consideration. The simplicity engineered into the aircraft has reduced per-flight man-hour maintenance requirements to less than that of any other first-line aircraft. The Skyhawk has an exceptionally high availability rating. The high availability rate is obtained with minimum manpower per aircraft. It should be noted that the high operational availability time and reduced maintenance manpower is another desirable saving in operation costs.